Alright, so in this video, we're going to do the even numbers. So first thing, let's look at number 2. So we need to factor completely. What should we do first? Take out the common factor. Anytime we factor, we want to take out anything we can. So we're going to take out a 2p to the 4th power. So then what are we left with? P squared minus 13p plus 42. Alright, now can we factor this? Do we have two factors of 42 that add up to negative 13? Negative 6 and negative 7. Awesome. So that 2p to the 4th power just stays outside. And then we have p minus 6 and p minus 7. Can we factor this anymore? No. So this is our answer. Factored completely.
I remember one of the problems before, you put like p squared minus 6 and then p squared minus 7. When do you do that? When do you put the square?
If this, good question. So if this was like 4, this is when we would put the square and the square.
Oh, okay.
So there's one in the homework that it had 6 here. So that would be cubed and cubes. Because our goal is to FOIL this back out and get p to the 6th power. So if it was a 4, we would break it down into 2 and 2. Since this is, well, this one was just a 2, that's why it's 1 and 1. Because we would FOIL this out and we would get p squared. Alright, let's look at number 8. So again, we need to factor completely. What should we do first? Greg.
That's it. 25k to the 5th power.
25k to the 5th power comes out. Perfect. So what are we left with? K to the 3rd power plus 64. So here we can see we have a perfect cube and a perfect cube. And we're adding them. So when adding our perfect cubes, so our formula, if we have a cubed plus b cubed, that would be a plus b times a squared minus ab plus b squared. If we were subtracting our cubes, our formula would be, if we had a cubed minus b cubed, we would break it down into a minus b, a squared plus ab plus b squared. But here, we're adding them, so we're only looking at this formula. So we need to find out what our a is and what our b is. So what's our a? Our a is k, and what's our b? What times what times what gives us 64? 4. Perfect. So now we just plug those things in. So that 25k to the 5th power just stays out front. Then we have a plus b, which is k plus 4. Then a squared. Then a times b, which is 4k. It should be minus 4k. And then plus b squared, which is 16. Can we factor this anymore? No. Trick question. We're done. Any questions here? So anytime you see that you have a perfect cube and a perfect cube, you're going to use one of these formulas. If you're subtracting them, you plug it into the first. If you're adding them, you plug it into the second. Alright, let's look at number 10. So factor completely. What can we do to factor this? Factor by grouping. So we group the first two, group the second. What can we take out of the first two? And then what are we left with? So we take out an x squared and we're left with x minus 7. What can we take out of the second two? You can take out a 5, and then what are we left with? X minus 7. So our insides are the same, so we can factor by grouping here. So what's our next step? We put the outsides together, so x squared plus 5, and then we put the insides in 1, so x minus 7. Can we factor this anymore? Nope. Even though we have an x squared, we're adding that 5, so we can't break it down. Any questions here? All right, let's look at 14. Again, we need to factor completely. I'm just going to rewrite it on the side over here so we have more room. 81 to the 4th power, 81 times g to the 4th power minus 625. All right, what do we do here? What do we know that's special about these two things? What is special about, this and this? What do we do? Oh, they're both perfect squares. Perfect. So what squared gives us 81g to the 4th power? 9g squared. Perfect. And what squared gives us 625? 25. So here we have 9g squared minus 25 and 9g squared plus 25. So since these are two perfect squares, we break them up. Can we factor this anymore? Yep, because we see that 9g squared minus 25 is another difference of perfect squares. So what would this break down into? 3g minus 5 and 3g plus 5. And then we can't break down the 9g squared plus 25, so that just stays there. Any questions here? Yes.
Why can't we factor out the 9g plus 25?
Because we can only do the difference of squares, so we can only break down two squares if we are subtracting. We can't do it if we're adding.
Okay.
Any other questions on 14? All right, let's look at 20. Determine whether the binomial is a factor of the polynomial. What do we have to do here? How can we determine if the binomial is a factor of the polynomial? Synthetic division. So what's going to go on the outside? Positive 2. Remember, you have to change the sign. And then what goes on the inside? 42, 143, 37, negative 27, and 45. Are we missing any terms? Nope, so we're good. Always got to check and see if you're missing any terms when you use synthetic division. Alright, so let's drop down to 42. Multiply. Add. All these are big numbers. 327. 227. Multiply. What do we get next? Add. Multiply. Add. Multiply. Add. So, is x minus 2 a factor? Nope. Not a factor. What would we have to get in order to tell if this is a factor? We would need 0 as the remainder, and then we could know that this is a factor. But it's not 0, so it's not a factor. Alright, any questions on 4.4? Alright, let's look at number 2. So we have 6h to the 5th power is equal to 12h cubed. What should we do first? Move the 12h cubed to the other side. So we subtract it on both sides. So we have 6h to the 5th power minus 12h cubed is equal to 0. What's next? Awesome. Always take out what you can. So 6h cubed. And then what are we left with? H squared minus 2. Can we factor h squared minus 2 anymore? Is 2 a perfect square? No. Nope. So can't factor it anymore. So this tells us to solve. So what's our next step in solving? Set them both equal to 0. So 6h cubed is equal to 0. H squared minus 2 is equal to 0. The first one, how do we solve for h? Divide by 6. So what's h going to be equal to? 0. The next one, what do we do? Add 2. H squared is equal to 2. Take the square root. So h is equal to what? Plus or minus square root of 2. Can't forget that plus or minus. So these are our 3 answers here. We have h is equal to 0 and h is equal to positive square root 2 and negative square root 2. Any questions? Ready for the next one? Yes. Number 4. What should we do first? Subtract 18w squared, move it to the other side. So now we have 4w to the 4th power minus 18w squared plus 81 is equal to 0. What's next? Can't take out a 9, but we can factor it. Do we have 2 factors of 81 that are negative 18? Greg, what are they?
9,
negative 9, negative 9. Perfect. So what goes into our parentheses? Yeah, w squared minus 9 and w squared minus 9. So here, since we started with a 4, that's why squared and squared. Alright, so what's next? What? Oh, well, we can factor it more. Or, since we're solving here, we don't even have to factor it more. We can just set them equal to 0. So, w squared minus 9 is equal to 0. W squared minus 9 is equal to 0. If this said factor completely, we would need to factor it more. But since we're just solving here, we don't have to factor it anymore. How do we solve the first equation? Subtract or add 9. So w squared is equal to 9. Square root. So what's w equal to? What's the one thing you can't forget when you take the square root of both sides? Plus or minus 3. And then the next one we do exactly the same thing because it's the same exact equation. Add 9, w squared is equal to 9, take the square root, w is equal to plus or minus 3. So our answers here are plus or minus 3. We wouldn't need to list it twice, but if you wanted to, you could. Any questions on this one? Alright, let's go to number 8. So we have to find the zeros and then sketch the graph. Alright, first thing, let's find the zeros. What do we need to do first? Take out a common factor. What's our common factor? X. Would there be anything else we should take out to make this a little bit easier? A negative x, just because we don't want to start with a negative. So when we take out that negative, this becomes an x squared. So it's, if we have a negative leading coefficient, we always want to take that negative out just to make it easier to factor. So x squared, what comes next?
Plus x.
Minus 30, because remember, we took out a negative x. So now do we have two factors of negative 30 that add to 1? What is it? 6 and negative 5. So that negative x stays on the outside. What goes into our parentheses? X plus 6 and x minus 5. What's next? Set them equal to 0. So negative x is equal to 0, x plus 6 is equal to 0, and x minus 5 is equal to 0. So what's x equal to in the first one?
0.
What's x equal to in the next one? And in the third?
5.
Positive 5. So we just subtracted 6 on both sides and then added 5 on both sides here. So we got our 3 zeros. Now to graph, we need to find our multiplicity of each of them. So how many zeros did we get as an answer? 1. So would our multiplicity be even or odd?
Even.
If we had 1 zero, is 1 even or odd? Odd. So our multiplicity is odd. If our multiplicity is odd, do we touch and turn or go through or cross? Cross and go through are the same thing. So do we cross or touch and turn? If our multiplicity is odd, we go through or we cross. Same thing. How many negative 6s did we get as an answer? 1. So is our multiplicity odd or even? Odd. If our multiplicity is odd, do we cross or touch and turn? We cross. And then how many 5s did we get as an answer? 1. So is our multiplicity even or odd? Odd. Do we go through or do we touch and turn? We cross. Alright. So So next we need to graph them. In order to graph, we need to figure out what our end behavior is. So first I'm going to plot the points. We have a point at 0, we have a point at -6, 4, 5, 6, and a point at 5. Yes.
What do you mean by cross?
Cross as in like it crosses the x-axis, or it goes through the x-axis.
Okay.
Touch and turn,
Okay,
I mean like it touches and turns.
How do you know if it crosses or not?
If your multiplicity is odd, it crosses. So anytime our multiplicity is odd, it's going to cross. If our multiplicity was even, it would touch and turn.
Okay.
Alright, we need to figure out our end behavior, so let's look at what we started with. We have a negative x cubed. So what is this going to tell us about our end behavior? Do we go up and down, down, up? Up and then down. Perfect. So since it's negative, the right one ends going down, and since it's odd, they go in opposite directions. So I'm just going to attach those two arrows to my farthest point on the left and my farthest point on the right. So up and down. Alright, and now we look at our multiplicity. So at -6, we cross the x-axis, so we're going to cross the x-axis. Then we make our way to 0. Do we touch and turn at 0 or cross? Cross, so we're going to go through. And then at 5, do we touch and turn or do we cross? We cross the x-axis again. So this is our graph. So when graphing polynomials, there's 3 things we need to check. First, we have to find the zeros, or solve, same thing. Next, we have to state the multiplicity. And that'll tell us if it crosses, if it's odd, and if it's even, it'll touch and turn. And then third thing we need to do is find our end behavior. And then we just put it all together in our graph. So 3 steps in graphing polynomials, right here. Let's look at 14. So we need to find all the real solutions of the equation. What should we do? P over Q. Perfect. We have 4 terms, so first thing we can check and see is if we can group, but grouping doesn't work because we won't get the same insides, so we have to do P over Q. So what are our factors of 24? 124, 6, 4, what else? 8 and 3, what else? 2 and 12. I think that's it. And these are the plus and minus of all of them. So how do we test our possible solutions now? Synthetic division. What's going to go inside the box? -1, -5, -2, and 24. What goes outside? Whatever we want. What do we want? 1. So we drop down the 1, multiply, add, multiply, add, multiply. 1 doesn't work. Come on, guys, you should know what works because you did this for homework. What should we try next? -2? So drop down the 1, multiply, add, multiply, add, multiply. Yay, it works. So negative 2 is one of our answers. So I'm just going to write that up here. X is equal to negative 2. What should we do next? Turn it into a polynomial function. So what do we start with? X squared minus 7x plus 12. What should we do next? Let's see if we can factor it. Awesome. Negative 3 and negative 4. So in our parentheses, we have x minus 3 and x minus 4. Is that it? What are our answers going to be? Yeah, remember, we got to set it equal to 0. So this is x minus 3 is equal to 0. X minus 4 is equal to 0. X is equal to 3. X is equal to 4. So our two other answers are going to be 3 and 4. All right, any questions on 4.5?
I'm confused with number 3.
Let's go back
in this
to
section?
number 3. All right. Oh. All right, let's do that one. So this was not one that we did because it's odd, but I'll do it with you guys just because it's a little bit different. So what should we do if we start with a number that's not 1 and we can't take anything out? Yes, we do this thing. We multiply the first and the last. So what's 16 times 1? Well, 16. Now we need to see, do we have two factors of 16 that add to negative 8? Negative 4, negative 4. So what's going to go into our parentheses here? Q squared minus 4 and q squared minus 4. When we start with a number that's not 1, what do we need to do with that number now? We divide both of our numbers in here by that number. We simplify if we can. So how can we simplify 4 over 16? 1 over 4. And what do we do with the rest that doesn't go in evenly? What should we do with this 4? Bring it to the front. So this is 4q squared minus 1. And this we do the same thing. It simplifies to 1 over 4. We take the denominator, whatever is left of it, and bring it out front. So this is 4q squared minus 1. It's equal to 0. And then next we just solve it from here. So we set both of them equal to 0. 4q squared minus 1 is equal to 0, and 4q squared minus 1 is equal to 0. How do we solve from here? Add 1. So 4q squared is equal to 1. I'm just going to move it over here so we have more room. What's next? Before we square root, divide by 4. So q squared is equal to 1 over 4. What's next? Now we square root. So what's q equal to? Plus or minus, what's the square root of 1? And then what's the square root of 4? 2. So plus or minus 1/2. And this is just one of them, but the other one's the same exact thing, so we'd get the same answer. So this is what you do when you start with a number that's not 1. So 3 is like this, and also number 1 is like it too, where you have to multiply the first and the last together. Any other questions on 4.5? All right, 4.6. Let's look at number 2. We need to identify the number of solutions. So how many solutions do we have in number 2? 5. Remember, we just look at our highest degree. So our answer here is 5. What about number 4? 6. Easy, cake. On to the next. Let's look at number 6. So we have to find all the zeros of the polynomial function. What do we do? Synthetic division, so we got to do our P over Q. What are all of our factors of 81? 1, 81. What else? 9 and 9. What else? 3 times what? 27. I think that might be it. Yep. All right, and what are all of our factors of 1? Just plus or minus 1. So all of these are whole numbers. All right, so what's going to go in the box? 1, negative 12, 54, negative 108, and 81. What do you guys want to try first? Any suggestions? Hopefully you guys did this for homework so you know what works. We can try 9. So multiply, add, multiply, add. I think 9's too big. All right, let's try 3. Multiply, add, multiply, add, multiply. What's 3 times 27? 81. 81 minus 108. Negative 27. And 3 times negative 27, negative 81. Oh, thank goodness it worked. So one of our solutions is x is equal to 3. All right, what do we do to find the rest of them? Make it into a polynomial function. So what do we start with? X cubed minus 9x squared plus 27x minus 27. Can we factor this? Nope. So what do we have to do again? Synthetic division. So now we have a new set of factors, of possible factors, because we need our factors of 27, but that really just eliminates 81. All right, what goes inside the box? 1, negative 9, 27, and negative 27. What should we try first? Three. Let's drop down the 1, multiply, add, multiply, negative 18, add, multiply. Wow, I'm good. We get 0 again. So 3 works. So another one of our answers is 3. What should we do next? turn it into a polynomial. So
Miss
this,
Carter,
yes,
why did we redo the synthetic division?
because we couldn't factor this. So like we got our answer here, and we couldn't factor it anymore, so since we can't factor, we have to do the P over Q again.
Oh, okay.
Alright, so turn it into a polynomial. What do we start with? X squared minus 6x plus 9. Can we factor this?
Yes.
What are two factors of 9 that add to negative 6? Negative 3 and negative 3. So this is x minus 3 times x minus 3. So what would our factors be here? 3 and 3. So here, our two other factors would be 3 and 3. So technically here we only have one answer because it's all the same. Any questions?
There's a polynomial that you can factor different ways, but you still want to do P over Q, so you do P over Q.
If you can factor this by grouping, try factoring it by grouping, but if it doesn't work, P over Q.
What if it doesn't work by grouping? Could you still do P over Q?
Yeah. You can always do P over Q. It'll work for everything. But it's a little bit easier just to factor it if you can. Like, in my opinion, grouping's easier than P over Q, but if you like doing P over Q, do P over Q every time. You can factor a trinomial using P over Q. You could factor this one here using P over Q. But it's easier just to factor it normally. Alright, for the sake of time, I'm going to skip 9 and 10 because there's not going to be a question like that on the quiz or the test tomorrow, so skipping those two. And let's look at number 12. So, are we missing any zeros here that's not explicitly given to us?
Yeah.
What are they?
1 plus
1 plus I? Anything else? Awesome, negative 2i. So anytime we have i's or square roots, we need the conjugates. So anytime we see an I, we need the positive and the negative. So if it gives us the negative, we have to list the positive. If it gives us the positive, we have to list the negative. And we need the plus or minus of square roots. So for these types of questions, you always need the conjugates of both of these. So what do we do next? What do we do? Casey, what's our next step? Awesome. X minus, we do x minus all of them. So x minus 2i, x minus, I'm going to say negative 2i, x minus 1 minus I, and x minus 1 plus I. Want to distribute the negative to simplify. So negative times negative is just x plus 2i. Which if you can see that this just goes in as a plus 2i, you could skip this step if you wanted to. But just don't work too fast to make some silly mistakes. So here we have to distribute, so x minus 1 plus I and x minus 1 minus I. How would we solve from here? So what we've done in the past is multiply all of this out and gotten our polynomial function. For the test, you just have to leave it like this. So leave it in the factored form. You don't have to multiply it out. Merry Christmas. So hopefully everybody's paying attention in this review. You just have to leave it in the factored form here. You do not have to multiply it all out. So this is your answer.